Hello, today we are going to learn about sound. Our lesson objective are to label the parts of a sound wave. Our keywords: sound wave, crest, wavelength, and wave amplitude. Let's begin with a warm-up activity about sound. So, what about sound? Sound is a noise we can hear, and hearing is using our ears to listen to sound. Vibration is a moving back and forth, and sound wave is a vibration that travels through the air. Okay, now let's see about what does mean vibration. Vibration travels through the air until they reach our ears, and we call this one sound wave. And sound waves the initial vibration is used to make a sound vibrate. The matters that the particles of the air are vibrating, and this one it will create a wave. Look at the picture. So this one, the speaker is producing a sound, and we can see compressions of particles, and these ones it can represented in a sound wave. So this one is a sound wave. We have different parts, we have different properties or characteristics. Let's take a closer look about each one. So what about wavelength? Wavelength is the distance between each crest. This one, we can consider it as a crest, or this one is a trough. Okay, look, and we have two sound waves. If you'd like to compare between these two waves, the blue one has a higher frequency because it has many repetition, it has many waves per second, and the red one has a lower frequency. Now look at this graph represented by the oscilloscope that show us a sound wave, and this one, the particles that are grouped together below, we call them compression, and it's at the same place of the crest. This one is the wavelength, and this one is the crest, this one is the trough, and we have here two cycles. The cycle begins from this point until this one, and so we have two cycles in this picture. We can identify sounds according to how they differ. Sounds can differ in pitch and loudness. Let's look at both terms one by one. The pitch of sound tells us how shrill or deep it's. It's like
hello.
Hello.
Observe that the girl's voice is shrill and the boy's voice is deep. Let's take a closer look. The pitch of a sound depends upon the vibration of sound in 1 second. That is the frequency measured in hertz. The greater the frequency, the higher the pitch, and the lower the frequency, the lower the pitch. Since male voices tend to be deeper than female voices, male voices have a lower pitch, or in other words, lower frequency. Let's consider two more examples: blowing of a whistle and call of a cuckoo bird. Which of these two actions will produce a higher pitch? In the case of blowing a whistle, a greater number of waves pass in 1 second. Look at the picture. A greater number of waves. Okay, now it means that it has a higher frequency, which results in high-pitched sound. In the case of a whoop bird, however, fewer number of waves pass in 1 second, resulting in a low-pitched sound. Now let's discuss the loudness of sound. The loudness of sound basically tells us how loud or soft a sound is. When you talk to our friends, our voice is soft. But when we address a public gathering, our voice is loud. So the loudness of a sound depends upon the amplitude of the vibrating object. The larger the amplitude, the louder the sound is, and it's measured in decibels. Consider this example. If we strike a drum lightly, we hear a soft sound. It's because the sound produced is of a low amplitude. However, if we strike the drum harder, we heard a louder sound. In this case, the sound waves have a larger amplitude. Okay, look at the graph. So this one has a larger amplitude. Now, hence the amplitude of sound waves determines the loudness of sound. The pitch of sound depends upon its frequency, while the loudness of sound depends upon its amplitude. So this is the difference between the pitch and the loudness of sound. Let's see now more characteristic, or to go more deeper about the properties of sound wave. We describe the frequency, the volume, the pitch, and the wavelength, and we have to label the different parts of a sound wave. Let's begin with a warm-up activity about the different parts of a sound wave. So this one is a sound wave, and this one is a wavelength because the distance between two crests. And now what about the amplitude of the sound waves? This one represents the amplitude of the sound wave, and this picture represents how many cycles or how many repetitions do we have in different sound waves. So it's about wave frequency. Again, so this graph represents sound waves and the different parts. Okay, this one is the crest, this one is the trough, the wavelength, and the amplitude. Okay, again the different characteristic of sound wave. So volume is proportional to the amplitude of the sound wave, and amplitude is the height of the wave. It's measured from the peak to the trough. Okay, the higher amplitude, like the wave on the right, means higher volume, and the lower amplitude on the left, like the wave on the left, means lower volume. Now, how are these different sounds? They are different from each other. For example, when a radio is playing, a siren from an ambulance, when a person is whispering, or you are blowing into a bottle. So because these sounds have different pitches, frequencies, and wavelength, and of course amplitude, so they sound different to our ears. Okay, how to distinguish between high frequency and low frequency? Now, okay, so the volume is measure of how strong a sound seems to us, and it depends on the amplitude of the sound wave. Okay, and amplitude is measured from its midline. What about pitch? Pitch is how high or low a sound is, and pitch depends on the frequency of a sound wave. Now it's time for a quick exercise. Take a minute and discuss with each other. Look at both waves carefully. Notice that both waves have the same frequency. This means both waves have the same pitch. Okay, look, same frequency. Now, the amplitude of the wave on the left side is greater than the amplitude of the wave on the right side. Remember, the loudness of a sound depends upon its amplitude, so the sound on the left side is louder. Hence, options A and C are correct. In this video, we learn about the pitch and the loudness of sound, and the pitch of the sound tells us how shrill or deep it is, and it depends on the frequency of the sound waves. The loudness of sound basically tells us how loud or soft a sound is. It depends upon the amplitude of the sound waves. An average human can hear a sound of frequency between 20 to 20,000 hertz, called audible frequencies.